So now we're going to divide radicals. We've added, subtracted, multiplied. And divide radicals is going to take a few more notes, and I put that note in the wrong place. So go back to the blank page right before multiplying radicals, okay? And we did it on this page for notes for multiplying radicals. We're going to go to this page. Too bad I didn't number that. That would have been much better. And we're going to divide radicals right here. Or just find a blank page someplace in your packet. We're going to divide radicals. Because there's a couple things we need to know about dividing radicals. When we divide radicals, and let me look back just a second. I want to not look back, but I want to show you. See where it says simplified? Make sure to rationalize the denominator. So let's talk about what does it mean to rationalize the denominator. So what they're talking about here is that when you are all done, if it is totally simplified, you can not, I should have started off, if totally simplified, I'm going to erase. If an expression is totally simplified, there are no radicals in the denominator. If it is totally simplified, there are no radicals in the denominator. And if there are, before we start simplifying, we have to do what's called rationalize the denominator. So to rationalize the denominator is that's what we're going to do. We're going to talk about that in just a second, okay? So leave some space right here. We're going to come back and do that. So I want to look at some examples. And do I have enough here? So I just drew a line here so I can come back to rationalize the denominator. And I want us to just look at some examples, kind of like what you're going to see on the homework. Is if I have, okay, so here's number 1. 8 square root 16 over square root 25. Okay? Oops, you can't see it. There we go. 8 square root 16 over square root 25. Okay, so look at these. What do you notice? 16 is a perfect square. 25 is a perfect square. So I know I said we couldn't leave any radicals, but first see if you can just simplify them. If they're perfect squares, not a problem. 8 times square root of 16 is 4. Square root of 25 is 5. So this gives me 8 times 4, which is 32 over 5. Okay, so that one's simplified. Number 2, we have 7 square root 3 over the square root of 9. Okay, so then 7 and square root 3 can't reduce, but 9 can, and that's just 3. I can leave a radical in the numerator. That's all fine and dandy. So this one is in simplest form. Now your temptation is going to be to reduce that 3 and 3. These are two totally different 3's. This 3 up here is a square root of 3. This 3 down here is just a 3. These are totally different. They cannot mix. You can't touch those. Okay? So that's what happens. That's what your first couple homework problems will look like. So example 3, I have 7 over the square root of 24. Just a basic problem, right? Is 24 a perfect square? Nope. But we can break it down to be the square root of 24, which would be perfect square, non-perfect square. Yes? Well, then that 7 just hangs out. Square root of 4 is 2. But I have a square root 6. Can I leave it like that? No, I can't. So hold that thought. We're going to come back there. So if I have let's just go to basic ones. Let's say that I have 3 over the square root of 5. Is 5 a perfect square? No. But what I have to do is I have to find something. What can I multiply to get that to be a perfect square? Don't overthink this. Just multiply it times itself. So I'm going to multiply it by the square root 5, yes? But remember, just like with fractions, whatever I do to the bottom, I have to do to the top. So I'm going to multiply both by square root 5. Okay? So you're going to, when you rationalize the denominator, it's basically, usually, let's say this, usually, if it is not a perfect square, just multiply by itself. Okay? So here we had a square root 5. That was our example problem. And now we're going to, and I should write that, let me do this again, so it's in the notes better. So there's our problem, and I'm going to rewrite it down here so you can see what I did. What I did is I said, hey, how do I get this to be a perfect square? Well, if I multiply by itself, doesn't that give me the square root of 25? Which, isn't that 5? Yes, it is. So that's our whole goal. Now, whatever I do to the bottom, I have to do to the top. So I'm going to take 3 times square root 5. Well, 3's on the outside, 5's on the inside, so that's just 3 square root 5. And I can't simplify it, so it just comes over. That's my answer. Okay? So to rationalize the denominator, usually you multiply it by yourself. We'll get into some other things that you can do with that, maybe today, maybe not until next year. Okay? So here we go, back down to number 3. We can't leave the square root 6 at the bottom. So we're going to multiply by, that's right, square root 6. That 2 is fine. It can stay down there. It's not under a radical. But whatever I do to the bottom, I have to do to the top. So I get 7 square root 6 over 2 times square root of 36. So that's 7 square root 6 over 2, what's the square root of 36? 6. And I can see some of you are going to go right from here to there. I'm fine with that, because you see that you're going to take a number times itself. This is basically, this you could also write as 2 times the square root of 6 squared. So that's where that 6 comes from, because that's squared in the square root. Okay, anyway, whatever your mind sees, that's good. Over 12. Okay, and remember you cannot reduce the 6 and the 12 because the 6 is underneath and the 12 is not. So that just gives you a basic idea of what we're going to be doing there. Okay, so for example 4, what we're going to do is look at this. Okay, I can't leave a radical in the denominator. 20 is not a perfect square, so I'm going to break that down. Just leave that top for now. So I'm going to break 20 into square root 4 times square root 5. Yes, because 4 is a perfect square that goes into it. So I get 3 square root 5 over 2 square root 5. Okay, what's the problem here? That's right, you cannot leave a radical in a denominator in order for it to be simplified. Now this one, kind of would just simplify, take those out. Do you see these two would cancel out? Okay, but for the sake of what we're doing, let's multiply by square root 5 on both. You were right, we can just cancel those out, but just humor me. So I'm going to multiply, I'm getting rid of the radical, so I'm going to have 3 square root 5 times square root 5 is 25. 2 square root 5 times square root 5 is 25. So I get 3 times 5 over 2 times 5. Now I know for sure those can cancel out. You could have canceled them here too. Okay, so we're going to get 3/2. Good. Okay, so in this one we have a square root 80 in the bottom, so we're going to simplify there. Now you might notice we could also simplify that top. If we want to, let's do that at the same time. So there's a perfect square in 8, that's 4 square root 2. 80, what's a perfect square in 80? Let's find out. 80 divided by 4 gives me 20, which means that it's probably 16. Yes, it is. So that breaks into 16 and 5. Okay? So that gives me 6 times 2 square root 2 over 4 square root 5. I'm just going to simplify a little bit there. Now I could simplify the 6 and 4, but I'm going to just wait. Over 2 square root 5. Okay? Now, can I leave a radical in the denominator? No, no. So I have to multiply to get rid of it. Again, I'm going to multiply by square root 5. So I have 2 square root 2 times square root 5. 12 has, sorry, that's a 12. 12 has nothing to multiply by, so it just hangs out. Square root 10. 2 times 5 is 10. On the bottom I have a 2. Square root 5 times square root 5 is going to give me square root 25, which gives me 5. I'm going to say that again. Square root 5 times square root 5 gives me square root 25. Square root of 25 is 5. But also, this could also have been written, square root 5 times square root 5 is also the square root of 5 squared. So see how the square and the square root can knock each other out. Okay? So now I'm going to have 12 square root 10 over 10. Oh, you see the temptation. You want to simplify those 10s. You cannot, because one's under a radical and one is not. But I can simplify the 12 and the 10. Others are both divided by 2, so I get 6 square root 10 over 5, because I reduced them both by 5. Okay? Good. Okay, let's look at your homework now. Go back to that page. Starts off pretty easy. Yeah, you can figure that out. And then these, they're not super complicated. Just do like what we've been doing, and hopefully we'll have some time or another worksheet or something to work on. These I'm crossing off, and they should be crossed off on yours because they're cube roots. We don't have to worry about those until Algebra 2. Okay? So that is your homework unless your teacher in Schoology tells you differently. Thank you very much. If you have questions, let me know.